How much heat must be removed to freeze 150 grams of water? We're not told the temperature of this water, so we're assuming that it's at the freezing point. So we take a rough sketch of what a heating curve might look like for water, where we have temperature going up and down and heat absorbed going from left to right. Might look something like that, where there's your solid phase, there's your liquid phase, and there's your vapor phase for water. We're going to focus on this area here because we're talking about a phase change, namely the freezing of water. Freezing refers to going from the liquid phase to the solid phase. And we're given this thermo data here. Liquid water is down here in the last row. And we're going to need this column because the molar heat of fusion tells us the energy required to melt 1 mole of that substance. But since freezing is the opposite process, we can take that same number and flip the sign. So that's how much energy must be lost by 1 mole of the substance to freeze. So let's start with what's given, 150 grams of water, and we're going to turn that into units of heat, namely kilojoules. We don't have a conversion factor that goes right from grams to kilojoules, but we do have one that goes from moles to kilojoules. And we already know how to convert grams to moles. Grams to mole is called the molar mass, and that information is off the periodic table. Now that we have a number in terms of moles, we can use this molar heat of fusion to turn it into kilojoules. So our answer to two significant figures is negative 50 kilojoules. So in order for 150 grams of liquid water to freeze at the freezing point, it has to lose 50 kilojoules of heat. Since the question is already phrasing it in terms of a negative quantity, removing is losing, you can answer the question in absolute terms. Give it a positive quantity.